Today is day 2 of alternating series, so I want to spend a little bit of time reviewing what we covered when we did day 1. So, you have your flip books out. I asked you to get them out. If you don't remember, you may look. But if you do remember, without looking, this is even better. I want you to think about what are the 2 things that have to occur in order for an alternating series to converge. I want you to talk to your table. If you have to look, you can look. But if you can do it without looking, don't look. Ready, go. What are the 2 things that have to be true? You remember? What's one of them? The limit has to approach 0 as n approaches infinity. And the other one is what?
A sub n plus 1 is less than or equal to a of n.
A sub n plus 1 is less than a sub n. In other words, the terms are getting smaller. So the limit has to be 0. Easy way to remember. Limit has to be 0. Terms are getting smaller. So in your flip book, let's go ahead and go to the picture of the flip book, which is right here. Why is that off center? There we go. Whoa. The limit is 0, and the terms are getting smaller. You say that it converges by the alternating series test, but if the limit doesn't equal 0, you say it diverges by the nth term test. Do you remember that? Yeah. You don't use alternating series for that. You use nth term. All right. Now, there were 2 other things you pasted in. The absolute versus conditional convergence. We talked about that just a little bit. We looked at both the alternating series and the non-alternating series. If they both converge, it's the alternating and the non-alternating, that's the absolutely convergent. If the alternating converges, but the absolute diverges, that's the conditionally. That's what we talked about as well. What we're going to be focusing on today is this. We talked briefly about this remainder last class. We're going to go back over it again to see if you understand it. It's called a remainder in some books. It's called an error in others. What today is going to be a focus on is how does the AP exam like to ask questions on this topic? How do they usually ask them? And I'll be honest with you, the math itself is easy. You just have to know how to read the question and set up the problem to do it. Okay? So that's the focus of today. How does AP ask these questions? This right here, as I make it get smaller, come on. Stop doing this. Anyway, there we go. Remember that E is the error and S sub n is the nth partial sum. So it'll tell you how many to go out. Do you go out 4 terms or 5 terms or 6 terms? We're going to practice on that today as well. So let me go back to the notes, which you have in front of you. This right here is a review of what it was saying before. If it alternates, it decreases, and has a limit of 0, it converges. If it alternates, it decreases, and it has a limit of 0, it converges. It's another way to talk about how this works. So once we do a problem, I'm going to put it more into a mathematical context because I know that errors are confusing. They were confusing to me when I learned them. And they come up a lot in the BC material. All right. So let's take a look at this first example. We have -1 to the n plus 1 over n factorial, starting at 1 and going to infinity. Part A says approximate the sum S of the series by using its first 4 terms. So we call that S sub 4. When you put a little 4 at the bottom, that means you're going out 4 terms. If you put a little 6, you're going out 6 terms, etc. So what I want to do is write out the first 4 terms of this series. So I'm going to blow it up a little bigger so you can see. Is the first term going to be negative or positive if I start at 1? Positive. It's going to be positive this time. Now remember that once you determine whether it starts negative or positive, you can ignore the alternator. The alternator is the -1 to the power. Just ignore it. So the top is now a 1, and the bottom is 1 factorial. Okay? Now the next sign is minus, because it's an alternating series. The top is still 1. What's the bottom? 2 factorial. Plus 1 over 3 factorial, plus or minus next, minus 1 over 4 factorial. I stop there because it says to go out 4 terms. I have 4 terms. So, do you know what 2 factorial is? 2. And 3 factorial is? 6. And 4 factorial is? 24. Now, question.
How do you know the top is 1?
Because once you remove, it's the negative 1 to the n plus 1 that makes it alternate. Okay, that's what changes the sign back and forth. So once that's gone, whoops, go away. There we go. Once that's gone, the only thing, excuse me, the bell's messing my head up. Once this is gone, the only thing left on top is a 1. Okay? All right. So what I want you to do, please, is take your calculator, and I want you to type that into your calculator and tell me what it is. We don't need to worry about the factorials because we know what numbers they are. So type in 1 factorial is 1 minus 1/2 plus 1 over 6 minus 1 over 24. And tell me what decimal you get. We're going to leave our answers in decimals today. Sometimes when you do these sums, you will get a negative answer, and that's okay. Whoops. What are you getting? 0 point what?
Wait.
625. 0.625 is what you should come up with. Okay? Now, let's pretend like this dot here is 0.625. That dot represents the estimate of the sum of all of the terms of this series. Now this is one of the series that we can't find the exact sum of. Do you remember what the 2 series are that we can? What are the 2 kinds of series that we can find the sum of? Geometric and telescoping. Very good. Okay? It should be. All right. 0.625 is close to the sum because as we keep going, the terms are getting smaller and smaller. So you're adding on or subtracting off tiny, tiny numbers. Okay? Now, what we're going to talk about is the error. And the error is basically saying, how far out am I going to go and find out how close I am? I know the sum is going to fall somewhere in there, the actual sum. I can't find what it is, but I can find kind of what zone it's in, what window it's in. Okay? Now notice question B. It says use the alternating series error bound to show that this approximation, the 0.625, differs from the actual sum or the actual value by less than 1 over 100. Now that's very confusing sounding, but it's very easy to compute this. Okay? Now, the one thing we talked about last class is the error is calculated by the term after the one where you stopped. The next term in the sequence. The error is the absolute value for this situation of the 5th term. We stopped after the 4th, so the error is the 5th. And the error is how wide my window is in either direction. Okay? So here you can see my computations for the first 4 terms. What would the next term in the sequence be? It would be 1 over 5 factorial, right? And its absolute value, which in this case would be 1 over 5 times 4 times 3 times 2 times 1 is 120. Okay? So that is the error value. Now take a look at what the question said. Use the alternating series error bound, that's it right there, 120, to show that the approximation differs from the actual value by less than 1 over 100. Is my fraction that I just got less than 1 over 100?
Yes.
Yes. So all you have to write is less than 1 over 100, and you're done. The actual value is off by 1 over 120, by less than 1 over 100. Okay? It's the question is asking, do you understand that the next term is the error? Okay? Do you understand that fact? And that's the calculation. That's all you got to do. So what does that mean in reality? What that means is this 1 over 120 is the width of the window. That's how far out you go in either direction, and you can be guaranteed that the sum will be in there. Okay? That's what the 1 over 120 is. It's the width of my window. Okay? And what that means is that, and that's where this formula comes from, S sub n minus E is less than S is less than S sub n plus E. This is the formula you wrote on your card. Let me kind of explain where this comes from. That's the generic formula for the window of error. Okay? Now, how many terms did we go out in our original problem this time? 4. We went out 4. So for this problem, let me show you how these two connect. Change the n to 4. That's for this problem. Okay? All right, let's see if I can move this over and blow it up so you can see both things. This 0.625, that was S sub 4, right? Isn't that S sub 4? Mm-hmm. Okay. This 1 over 120, both of these, that's E. Both of those are E. Can you tell me, please, what number on the number line goes there? How would I find that number that goes in the box? I would take the 0.625 and I would subtract 120. Do you agree with my statement?
Yeah.
So that's the same thing as that, S sub 4 minus E. Okay? How would I find that box over there? I would add the error to the S sub 4. That's where this comes from. So my sum is somewhere in the middle, somewhere around 0.625. But I don't know exactly what it is, but I do know it's between the sum plus the error and the sum minus the error. Okay? Now, this knowledge is what you need to do part C, excuse me. Do you have any questions about what I just said? Do you now understand what this formula means?
Yeah.
You go left and you go right. Okay. Use your results to explain why S cannot be 0.7. Okay? Let's actually calculate what goes in those two boxes. Okay? So I'm going to erase this and this, and I'm going to put the numbers in. S sub 4 was 0.625 minus E is 1 over 120. Is less than S. Now, I can never find S exactly. And then S sub 4 is 0.625 plus 1 over 120. So, take your calculator, calculate the number on the left, that's the left-hand box, and then calculate the number on the right, that's the right-hand box. Okay. So what did we get? Did you guys get the same answers that I got? Yes. Okay. So I know that the true sum of all of the terms is somewhere between 0.6166666 and 0.6333333. Okay. Now, do you understand why the sum cannot be 0.7?
Yeah.
Yes. Now, you can't just use the work to show you that. You got to put a sentence on there. It says explain why. Explaining means not just math. You got to give me some words to go with it. since the sum must fall between 0.616, you can round it to 3 decimal places if you want to, and 0.633, the sum cannot equal 0.7. That's enough. That basically says you understand what that math means. You didn't just write down math and then you thought that was plenty. Questions? So have we done a whole lot of hard calculus today?
No.
Not really. We haven't done a single derivative. We haven't done a single integral. That's it. Okay? Questions? All right, we have one more problem to do, and it's at the bottom of the page. And this is another common one they like to ask. Were you all done writing that down, by the way? I heard a no, so I'll wait just a second. Everybody else good?
Yeah.
Okay. Move. The next question says, how many terms are needed to approximate the sum of the series so that the estimate differs from the actual sum by less than 1/1000? Justify your answer. That seriously is a very scary looking problem. Okay? But this phrase here, please underline that phrase, highlight that phrase, whatever. Anytime it talks about the estimate differing from the actual sum, you can replace all of that with the word error, because that's what it means. So now if you reread the problem, it's not quite so bad. How many terms are needed to approximate the sum of the series so that the error is less than 1/1000? That's a little better. It's a little better. Okay? So, the last problem I said go out 4 terms and then find the error. This time I'm saying I don't know how many terms to go out. How far should I go so that the error comes out to be less than that? Okay? So here's what we're going to do. We're going to take this sequence. Let's go ahead and write out a few terms on this thing. S sub n, I don't know how many I'm going to go. Does it start negative or positive?
Positive.
Positive. So the top is a 1, and the bottom is 1 to the 4th, which is 1. Then minus 1 over what? 2 to the 4th, 16, plus 1 over 3 to the 4th. Do you know what 3 to the 4th is in your head?
68. Oh, 316.
Nope. 81. There you go. Dot, dot, dot. And the nth term is going to be what you see in the sigma. Negative 1 over n plus 1 plus over n to the 4th plus. And they actually like you to say that it keeps going past that.
Okay.
Because it does. Now, just out of curiosity, if it wasn't alternating, what kind of series would it be?
P series.
It's a P series. Very good. Yes, ma'am.
Okay, how do you know that that's being added and not subtracted?
You don't. That's why you put the negative 1 back in there, because whatever it is, if it's positive, it'll be fine. If it's negative, it'll change the sign for you. Okay? She was asking, how do I know it's a plus sign right there? I don't. Putting back in the alternator will make it be whatever sign it needs to be. Okay? So, remember that error is absolute value. So when we do the error, that will be the nth term, because I don't know which one it is. So it's going to be the absolute value of 1 over n to the 4th. And what is my error supposed to be? It's supposed to be less than 1 over 1000. Okay. So, because I'm doing absolute value, and I know n's going to be positive, I'm going to go ahead and take the bars off. So 1 over n to the 4th is less than 1 over 1,000. Now I just need to do the math. How do I do the math? This is algebra.
Multiply.
Multiply what?
Whichever. N to the
It's
fourth.
dangerous to cross multiply with an inequality. Yes, you could, but you got to be very careful. So let's avoid that for now.
N to the fourth.
Okay.
Multiply by n.
Let's multiply by the n to the 4th because I don't like it on the bottom. So we're going to do an n to the 4th here and an n to the 4th here. These two will cross out. So that's 1 is less than 1/1000th n to the 4th. Okay, what's next?
Multiply by 1,000.
Multiply by 1,000 I think is a good idea. So 1,000 here, 1,000 here, those cross out. I like my n's on the left, so I'm going to take the whole thing and flip it over, and I'm going to have n to the 4th is greater than 1,000. Do you agree with that statement?
Yeah.
Okay. How do I take the power off the n?
Take the quadruple root.
Take the 4th root. Now, I would say about half of you in here may know where on the calculator your 4th root button is. But there's another way to do this where you don't have to know that.
Just raise it to the 1/4.
Raise it to the 1/4 power. We've talked about that before. So 1/4 power, 1/4 power is a much safer way to go. So 1,000 up arrow, 0.25, 1/4, same thing. And you get 5.623. I know I'm running off the page, that's where I'm stopping there. Not going any lower. Okay. So, what does n represent again? The number of the term number that I've gone out. Can I have a 5.6 term?
No.
No. So what would that actually be?
6a.
Now, yes, you're right, it is the 6th. So this n represents the error. So the error would be the, which term did you just tell me? 6th term. The, whoops, I meant to write the error for the series would be at the 6th term. The error of the series would be at the 6th term. Does that make sense to everybody?
Yeah.
Is that what the question was asking me, where the error is?
No.
Not exactly. What did it say at the beginning? How many terms do you need to add up? So if the 6th term is the error, how many terms should I add up? 5. Very good. Comma now. So 5 terms should be used to approximate the series. Let's address it exactly as the question asked. It said how many terms are needed to approximate the sum? Approximate the sum of the series. Let's even be more specific. The error of the series would be at the 6th term, so 5 terms should be used to approximate the sum of the series. Now, do you see how that could be, if you don't quite understand, you could say that 6 terms would be needed, because n is greater than 5.6. If you don't explain yourself, that could be misconstrued as the wrong answer. That looks like how many terms should be added. No, that's the error term. So you got to subtract one as far as how many you add together. Are we good on that?
Yeah.
That's it, guys.